Hello, mathematicians. You know how I love great math vocabulary, and today we have some new terms: function, input, and output. And what happens is the input is what you put in. It goes through some rule. That's kind of like our function machine. We call that the rule. Is it going to be +2 times 10? What's your rule going to be that then creates your output or what comes out? So often mathematicians will organize that in input and output tables. So here we have an input-output table, but we're going to apply it to a real-life problem. So the input is the number of days, and the output is gallons. Let's read the problem that shows this. Each person in the US uses 50 gallons of water per day. Wow, that's a lot. Use this information to complete the table below. So on day one, the person has used 50 gallons. Then on day two, they've used 100 gallons, right? What rule are you noticing to go from the input through the function machine to the output? What rule are you doing to go from 1 to 50 or from 2 to 100? Did you notice that it's times 50, right? Because 50 gallons per day. So now that we have our rule, we could do times 6. I'm sorry, we could do how much water was used after 6 days pretty easily, right? All we have to do is take 6, the input, apply the rule, times 50, and we'll get our output. 6 times 5 is 30, 0 in my factor, 0 in my product, 300 gallons by day 6. Same for the input of 7. If we had 7 as our input, our rule is times 50. Then I'm going to get 350 gallons as my output. Okay? And finally, if we had 10 as the input, take your input, apply your rule. Can you solve this one? What'd you get? 500 gallons as your output. Okay, so let's do a few more. Sometimes you're given the output and asked to find the input. So here they drew the function machine for you, right? That's basically just means the rule that's happening. And you're told that your rule is +5. So let's go ahead and complete this table. Well, this first one I'm gonna do. If the input is 5 and my rule is +5, my output is going to be 10. Not so bad, right? But sometimes they're going to give you the output and you have to think what the input would have been. So this is basically saying blank, some input, plus 5 more would give you 15. What goes in that blank? 10. Now, what's kind of cool is that we know to go from input to output, you added 5, right? Well, if you want to go from output to input, you do what? Subtract 5, right? 15 minus 5 brought me back to 10. So these addition and subtraction, these are known as inverse operations. And I always remember that by thinking the inverse undoes. The inverse undoes, right? So now you can go ahead. I want you to fill in the rest of these 3 blanks and play back the video when you're ready to see the answers. Okay, check your work. So you should have gotten 17, 18, and 33 in those blanks. And then the question asks, what patterns do you notice? I think I told you this a while ago, but when you hear this word patterns, A, you can know that there's more than one right answer. So there's a variety of possibilities. But B, it's really helpful, I find, to think about evens and odds. That's a nice way to spot a unique pattern. Because, I mean, you could say here that the output is always 5 more than the input, But if you write that, I'm going to say, duh, right? That was our rule. So let's try to come up with something a little more sophisticated and interesting. And use this vocab evens and odds might be helpful. So I notice in this first example, 5 was an odd number, and then 10 was an even number. Maybe I'm onto something. In the next one, the input was even, and the output was odd. Oh, look at that. The next one, even input, odd output. And so, okay, so when my input was odd, it came out even. When my input was even, it came out odd. I'm going to write that. With an even input, you get an odd output. And I'm going to teach you a fun phrase that will save you time. We could write, and with an odd input, you get an even output, or you could say, and vice versa. And that phrase just means basically the same if you flip it, but it saves you a lot of writing. Okay, let's look at another function machine. This time it's multiplication. Our rule in our function machine is times 4. So I want you to pause the video and fill out the blanks. See if you can solve these too, where it gives you the output, but you have to do the input. Let's actually do one of those together. If it gave me 20, I'm asking myself blank times my rule times 4 equals my output 20. Do you know what would go in that blank? You're right, 5. So we could also think, remember, from in to out, this was times 4. So if we want to do our inverse operation, meaning the inverse will undo it, what would be the inverse of multiplying by 4? Dividing by 4. And hey, that would have worked here, right? My output was 20. I divided by 4, and that brought me back to this 5. Okay, so go ahead now pause the video, give it a try. Okay, go ahead, check your answers. Did you get 12, 20, 8, and then 12 again, but this time 12 is an input? Yeah? Okay, now let's talk through what patterns. Again, you could technically say that your output is 4 times as much as your input, but to that I'm going to say, duh, that was our rule. So let's get a little bit more creative, use some of our vocabulary with evens and odds. That's a good go-to for finding patterns. So if I look at this, I'm looking at my outputs now, 12, 20, 20. Oh, I had a repeat on there. Sorry about that. 12, 20, 20, 32, and 48. I am noticing all of those are even. That's a pattern. I could say all outputs are even. And that makes sense since they're going to be all multiples of 4, right? Since we're multiplying by 4, that they would be even as well. That's not the only right answer. Maybe you notice a different pattern, but we want to make sure we give a complete answer with math vocabulary.